So in this lesson, we are going to look at 3D trigonometry. And as usual, just to remind you how we do mathematics. So make sure you understand each step. Don't just go on if you don't understand it. Then mathematics is not something you watch, it's something you do. So if you see the pause button, then press the pause and do the sum on your own. And then, very important, whatever you do, just make sure that you mark it, because that is the way we learn through our mistakes, so that when you mark it and you see where you went wrong, you'll just see what needs to be done to get it right. Okay, so we are going to look at two sections. We've got calculations, and then we're going to look at proofs. Now, in the 2D trigonometry video, we looked at this, so I'm just going to briefly remind you on this, because this is especially applicable also in 3D trigonometry, and that's basically where we have this person at point A, perhaps. We've got this horizontal line that runs parallel with the ground. Then this line from person A to person B, if you take the angle between this horizontal line and this line of sight, this angle is called the angle of elevation. So they will say angle of elevation of B from A. And then in the same way, we've got the angle of depression. If you take from the horizontal, you go down, that angle is called angle of depression. All right, now the first example we're going to look at is in an instant of time, a bird is at point C. Two bird watchers at A and B are looking up at the bird. The height of the bird is CD, where D, A, and B are in the same horizontal plane. AC is 65 meters. Then we've got CB, which is 40 meters. We've got angle of elevation of C from B is 53, and the angle ACB, so ACB, that's in this slanted triangle, is 45 degrees, and ABD is 42 degrees. All right, now let's see what we need to do. So for A, they say how far are the bird watchers from each other. So we know that the bird watchers are at A and at B. So actually they're just asking what is the distance between A and B. Okay, and when we look at where the information is and what triangles we can use to apply it, AB lies in two triangles. It's in either the one that's the horizontal plane that's on the ground, or it's the slanted triangle. So let's see where's the information, where is enough information that we might be able to apply. Now we can see that in triangle ACB we've got these two sides and an included angle, and immediately that should remind you of the cosine rule. And the cosine rule actually uses the side that's opposite the given angle. So that's going to be our go-to. We're going to say the cosine rule. So it starts with AB squared, which is equal to then AC squared, so AC squared plus BC squared minus 2 times AC times BC times cos of this angle C. Okay, now to solve for AB, I can take the square root. So in one step, I'm basically going to take the square root and I'm going to substitute in all the values. Okay, so AC is 65 squared plus BC is 40 squared minus 2 times by 65 times by 40 times by cos of 45. Okay, and then we can just type that onto the calculator. So that gives us 46,35. Okay, and this is in meters. Right, now for B, how high is the bird? So this is the height of the bird, which means that we're basically just going to calculate the distance of CD, or the length of CD. Now, this we can assume is a right angle triangle because this height obviously is perpendicular to the ground, all right? Then where do we have enough information? So this triangle actually has an angle over here, and the side we want to calculate is the opposite side, and a known side is the hypotenuse side. So we know opposite and hypotenuse is sine. So I'm going to say sine 53 is equal to opposite, so CD over hypotenuse, which is 40. To solve for CD, we can just cross multiply the 40 up. So CD is equal to 40 sine 53, and then we calculate that. And that's 31,95. Okay, and that is also in meters. Right, so the final one, calculate the area of the triangle that the bird watchers form with the bird's shadow if it fell directly below the bird. So this is where the shadow would fall then. And then the triangle that they form are ADB. Okay, so we need to find the area of that triangle. And to find the area, we need two sides with an included angle. Now, we just calculated AB. We calculated AB as 46,35. We also calculated CD. Yeah, we calculated CD. Right, so we actually need DB. Then we can use DB and AB with the included angle to find the area. So we still need to actually calculate DB. And we can do that also with one of our trig ratios, and that from this angle, that is going to be the adjacent side, and then we also have the hypotenuse. And adjacent over hypotenuse is cos, so I'm going to say cos of 53 is equal to adjacent over hypotenuse, so that's dB over 40, and then just solve for dB again. So multiply the 40 up, we got dB equals to 40 cos of 53. Okay, and then we use our calculator. And that's 24,07. Right, then we can go ahead, so this is 24,07, and now we can just say, okay, the area of triangle, what is it, ADB is equal to half times by the 46,35 times by the 24,07 times by sine of 42 degrees. Okay, and then the easy part. So I'm just going to type 0,5 instead of 1 over 2. That's just my preference. And then times by 46,35 times by 24,07 and times by sine 42. Okay, so that gives us 373,26. Okay, and remember the units, because it's area, it's going to be meters squared. Right, now for question 42.1. In the diagram, H represents a hot air balloon held in place by 4 wire stays AH, CH, BH, and DH. Whereas ABC and D are in the same horizontal plane, ADC are collinear, and then AH is equal to CH. So AH is equal to CH, the same distance or length, and HD is perpendicular to AC, AH is perpendicular to AC. HAC is 37, then we've got CIB, which is 32, we've got ACB, which is 57, and HD is 30. Okay, and AB is K over there. Now determine or calculate AH. Now AH runs here, and this is in a right angle triangle, so this is quite easy. We just have the opposite side which is given, and we want the hypotenuse. Opposite and hypotenuse is sine. So I'm going to say sine of 37 is equal to opposite 30 over AH. And AH is the one that I need to solve for, so I'm just going to bring AH up, and I'm going to bring sine 37 down. So AH is equal to 30 over sine 37, all right? And then we just calculate that. 30 over sine 37 is equal to 49,85. Okay, do we have units? Yes, it's in meters. Then for B, determine the value of K. All right, now we can see that K is in, well, two triangles. We've got AHB, but there's no information there, so we are definitely going for ABC to work in that triangle, because we've got another angle there, and then obviously we can calculate AD, but now we actually need AC, that whole length over there. And the first thing we want to go for is to see if we can use sine, because we either need to use cosine or sine because it's not a right angle triangle. So if we want to use sine, then this is our side, and that's the opposite angle. And then we're obviously going to work with this long side, so we'll need this angle, which is quite easy to get because we have the other two angles. And now our main aim or goal is to find AC. So since it's given that AH is equal to HC, it definitely look okay. We then obviously know that this angle will also be 37 because it's equal angles opposite equal sides. This is a common side, and that means that this DC will be equal in length to AD. Okay, so if we can find AD, we can just basically multiply it by 2, and that will give us DC. Okay, now to find AD, we just say opposite and adjacent, so that's tan. So tan of 37 is opposite over adjacent AD. Okay, so solving for AD again, bring AD up, take tan 37 down, so AD is equal to 30 over tan of 37. Okay, let's calculate that. And that's 39,81. Okay, and that's obviously also equal to DC. So if we want to find AC, it's going to be equal to 39,81 plus 39,81, and then so we can just take this and multiply it by 2, which is then 79,62. Okay, now that we have that, so we can write that 79,62. We can also find angle B. So B will be 180 minus the 57 minus 32. Okay, and yeah, we can actually just give it a reason angles of triangle, and then 180 minus 57 minus 32. Okay, that gives us 91. So it's very close to a right angle, but it isn't. So we're going to use sine, the sine rule. All right, so we want K. So I'm going to begin with K. I'm going to say K over sine of 57 is equal to AC, which is 79,62 over sine of 91. Okay, solving for K, we just take the sine 57 up, so we have 79,62 times by sine of 57 degrees actually, and then that's over sine of 91 degrees. Okay, let's work that out. 66,79. Okay, and that is in meters. Right, so that one's done. So question 42.2. In the diagram, B, C, and D are three vertices of the floor of a rectangular wall. So just to stop there, rectangular wall means these are right angles. Then A is a light on the ceiling so that B, A, and D are in the same vertical plane. So B, A, and D, this forms a triangle right here that's like standing upright, if you think about that. And the angle of elevation of A from B is 17,5 and BC is 12. Where's BC? BC is 12, CD is 35, and BA is 30. All right. So what do we need to do? In A, calculate the height of the light above the floor. Very easy. This is the height. Let's maybe call it H. And this is in a right angle triangle. So this is going to be opposite over hypotenuse, which gives us a sine. So sine of 17,5 is equal to opposite over hypotenuse. So then we just get rid of the 30, multiply both sides, or to cross multiply. So H is equal to 30 sine 17,5, and then work that out. Okay, that's 9,02. Right. Now for B, calculate the length of AD in meters. Now, this seems like AD might be equal in length to BA, but that's not stated. If the light was in the middle of the room, then it would have been, but it's not given. So we're going to have to go the long way and actually calculate AD. All right. Now, if we look at AD, we can see, okay, that's in this triangle. And if we can find BD, we've got two sides with an included angle, and then we need to find the opposite side, which gives us enough information to use the cosine rule. So now finding BD. So if we look at this information given over here, this is a right angle triangle. So very easy to find BD. We're just going to use Pythagoras. So we're going to say that BD squared is equal to 12 squared plus 35 squared. You can just say Pythagoras. Okay, and then solving for that, we just take the square root. Okay, and calculate. So that's 37. Right. So now that we have that 37 over there, we can apply the cosine rule. So that's AD squared. Okay. And that's going to be 30 squared plus 37 squared minus 2. 30, 37 cos of 17,5. Okay. Take the square root. So we've got AD is the square root of all of this. 30 squared plus 37 squared minus 2, 30, 37 cos of 17,5. All right. And then just long list to type. Okay, so that gives us 12,32. Okay, and that is in meters. And then we are done. So that is for calculations. Now let's move over to proofs. Okay, now in the diagram, Q is the foot of a vertical tower PQ, while R and S are 2 points in the same horizontal plane as Q. the angle of elevation of P as measured from R, so angle of elevation from P as measured from R is X, and then RQS is Y, and what's this? No, sorry, RQS is the angle, that's Y, and QS, this QS is A, okay, and the area of triangle RQS is A meter squared, so this area of RQS is A meter squared, that's the area. Okay, now to look at the question, in the example, okay, yeah, so we've just seen that. Prove that PQ is 2A tan X over A sine Y. All right, now, like we've done with the proofs in 2D trigonometry, we used a link, and we're going to do the same here. This one is slightly different because now it all of a sudden includes an area. So this triangle has an area, and we know from the area of a triangle when it's obviously not a right angle triangle, we need two sides with an included angle. So far we've got this side, this angle, so we kind of need this side, all right? And if we look at what's given here, PQ lies in this triangle. So this PQ can be connected to this side as well, which means this side would then form our link, okay, where we're going to find PQ in terms of QR, the link, and then we're going to find the link in terms of the area, okay? So the area formula, so we're going to use the area formula as that's the only difference here. We're going to use the area formula instead of like trig ratios or sine or cosine rules. All right, now to start, we want PQ in terms of QR, and in this triangle, this is a right angle triangle, and from this angle, this is the opposite side and this is the adjacent side. So we are going to say that opposite over adjacent is tan. So tan of X is equal to PQ over QR. And I want PQ in terms of QR, so I need to solve for PQ. We're just going to take QR up. Then we have PQ is equal to QR tan of X. Okay, so that's done. Next, we need QR in terms of the area. So here we're going to start by writing the formula for the area. So area of triangle RQS is half times by A, which is one side, times by QR, which is the other side, times by sine of Y. All right. Now, we're also given that this area is equal to A. So I'm going to substitute that in. So A is equal to half small a QR sine, let's just put that there, sine Y. Now, we want QR in terms of A, so we need to solve for QR in this case. And to do that, think again about cross multiplication. So this 2 is in the denominator, so I'm bringing it up, okay? Whereas this A is in the numerator, so I'm going to take the A down, and also the sine Y I'm going to take down, okay? So this is just cross multiplication. There might be other ways to think about it, like just multiplying both sides by 2 and dividing both sides by A and sine Y. All right, but we end up with QR equal to, or actually let me not confuse you by turning that around. Let's just first do it as it is. So if we take the 2A, 2 goes up, and then A comes down, and sine Y comes down, and that's then equal to QR. All right, now we have QR, so now we can take QR and substitute this value of QR in terms of A into our first equation. So PQ is equal to all of this 2A over A sine Y, and then after that substitution tan X. Okay, so now let's see what the original one looks like. So basically we're almost there, we just need to write it in the same format. So this is 2a tan x over a sine y. Alright, that is done. So the next question, calculate the value of y. So we're just going to clean the screen. So calculate the value of y if PQ is 77, A is 89, the area is 1480 and x is 46.5. Now we have to basically just substitute in the known values and solve for y, which is over there. So let's start by substituting. So we've got 77 is equal to 2 area 1480 and then tan of 46.5 all over. So A is 89 and then sine of y. Alright, now obviously I want to get this thing on its own. Alright, and again I can use cross multiplication by basically, if you think about this as over 1, maybe this sign can cross multiply, go up there, and the 77 can come down. So sine of y is equal to all of that to 1480 tan 46.5 all over 89 times 77. Okay, now to get y on its own, we just take the inverse of sine of this whole business over here. So y is equal to the inverse of sine of everything to 1480 tan 46.5 over 89 times 77. Okay, and type it in. So we're going to say shift sign 2 times 1480 times tan 46.5 over 89 times 77. Okay, so that's 27.08. And remember, y is an angle, which means it's in degrees. Right, so question 43.1. In the figure, DC represents a tower standing on the horizontal plane ABC. The angle of elevation of D from A, so angle of elevation of D from A is x, and C is north y degrees east. Okay, now to explain this, I'm going to just draw this triangle flat. So let's say we are viewing this triangle from the top. All right, then we have A, C, and B. Now, when we are at this point, north will obviously be in that direction. And then if we have north, east, so north and then east is this side, east, but how many degrees? Y degrees, okay? And the same happens with north, Z degrees west from B. So if we at B, working from B, north is north, but north has Z degrees in western direction, so that's going to be Z over there. Right, but now if we are working inside this triangle, remember this is 90 degrees, north and east are 90 degrees from each other, so this will then be 90 minus y, this angle here, 90 minus y, and this angle will be 90 minus z. Okay, right, so we can actually put it in 90 minus y and 90 minus z. All right, now prove that AB is h sine y plus z over tan x cos z. AB, so where is AB? AB is this side over here, and then h is that side over there. So very straightforward. We've got our two triangles. One is a right angle triangle, one is not. And we have the link, which is common in both triangles, is AC. So I want to find AB in terms of AC and AC in terms of H. All right. And finding AB in terms of AC, let's first go for the sine rule. Let's see if we can apply the sine rule. To do that, we've got this angle with that side. And then AB is another important side, but that means we need the angle of C, ACB. So Finding ACB, also pretty straightforward, just we've got angles of a triangle, so it's going to be 180 minus this angle minus this angle. So let's write that out. We've got ACB is equal to 180 minus 90 minus y, and remember to put it in brackets obviously because it's the entire angle that's getting subtracted. 90 minus z. Okay, if we multiply those brackets out, we've got minus 90 plus y minus 90 plus z, and then 180 minus 90 is 0, so we're just left with y plus z. Okay, now this is y plus z, which means we've got that angle which we can use with that side. Okay, I want that side, so I'm going to start with that side, AB over sine of y plus z is equal to AC over sine of 90 minus z. Okay, now two things. We want AB in terms of AC, so we need to solve for AB. So we're taking up this, and also in the same step I'm going to use a reduction formula to simplify the sine 90 minus z. So AB is equal to AC over AC multiplied by sine y plus z, okay, and that's over cos of z. All right, that done. That was the hard part, actually, the hard triangle. Now the easy triangle, which is the right angle triangle, we want to find AC in terms of h. So AC and h from this angle over here is opposite and adjacent, so that's tan. So tan of x is equal to opposite over adjacent, which is AC. Then to solve for AC, AC comes up and tan x comes down. So AC is equal to h over tan x. Now that we have AC, we can go back to this first formula and just substitute AC in there, right? So this AC's value. Now two ways we can do it. I think the easiest way might be just to take AC and put it in front of this whole bracket, or we can just plug in AC as it is there, and then we're going to have a not bracket, a fraction. Then we're going to have like a fraction in a fraction. So maybe let's just do that. So we have h over tan x times by sine y plus z all over cos of z. Right. Then remember, numerator times by numerator, denominator by denominator, and then if you divide by this, it's the same as saying multiply by 1 over cos z. So that's also going to be multiplied 1 over cos z. So cos z is going to be here in the denominator again. So to write that, we've got h sine y plus z over tan x cos z. Okay, and that looks like what we needed to prove, so that means we are done. Right, now for B, use a calculator to calculate AB. If h is 33,7, x is 23,4, y is 51,4, and z is 57,8. Okay, very easy. We're just going to substitute. We actually don't even need to solve for anything because AB is already the value that we're going to get. So AB is equal to h 33,7 sine, and then y 51,4 plus z 57,8 over tan 23,4 and multiplied by cos 57,8. Okay, 33.7 multiplied by sine 51.4 plus 57.8 over tan 23.4 multiplied by cos 57.8. Okay, so that's 138,01. Okay, do we have a unit? Yeah, it's meters. Right, that is question 43.1. Then moving on to 43.2. In the figure, A, B, and C are in the same horizontal plane. Then a balloon at P is directly above C. The angle of elevation of P from A is theta. ABC is 90 minus alpha. And the distance from B to C is half the distance from B to A. Okay, so this is half of that, where BA is D units. So immediately we can basically say, okay, if that's D units, then BC will be D over 2 units because it's half. Right, now show that H is all of this. So where's H? H is over here, okay, and then the other variable side that's applicable is D. So we want to find H in terms of our link here, and then work from the link to D. Right, let's just write that down. So H in terms of AC, and then from AC to D. Okay, so the first one is the easy one. From theta, H is opposite and AC is adjacent. So opposite and adjacent is tan. So tan of theta is equal to H over AC. Okay, we want H in terms of AC, so solving for H, we have AC tan theta. Okay, now moving on, we want AC in terms of D. Okay, so here, are we going to use the sine or cosine rule? Immediately I see that we have two sides with an included angle and then the opposite side. So this definitely resembles the cosine rule. So if we're going to calculate that, we've got AC squared is equal to this side D squared plus the other side D over 2 squared minus 2 times by D over 2 times by cos of 90 minus alpha. Okay, now to simplify. So starting, we can actually take the square root so long, okay, of everything, and also we can simplify this term, that term over there. So this is D squared plus D squared over 4, because it's squared, minus, so this 2 and 2 will cancel, and then D times D is D squared cos of, what do you have there? So this is the reduction formula I can apply here. So this becomes sine alpha. Okay, and all of that in a square root. Okay, now here these two are actually like terms because it's D squared, and we can actually change this one to become 4 over 4. Like because if we want to add, obviously we want the numerators to be the same because we're adding fractions. Okay, so when you add fractions, it's 4 plus 1. You just add the numerators and the denominators remain the same. I hope you remember that from primary. So that is then 5d squared over 4 minus d squared sine of alpha. So I obviously can't add this term because of the sine alpha, which makes these two terms not being the same type of terms. There's a word for that, but anyway. Okay, so now next thing I want to do is, because we're in a square root and we can see actually d squared is a perfect square, which we can kind of take out. 4 also is a perfect square. So how can I take 4 out? Now if I want to take out 4, obviously I would need a 4 here, because if you want to take it out, you're going to have a common factor. So we can put a 4 there. If we put a 4 on the top and the bottom, then we can put a 4 here. Okay, so now we can take out d squared and we can take out 4. Let's just take it out as a common factor. So d squared over 4 comes out as a common factor, and what's left is the 5 minus, so if I take that 4 and that d, then 4 sine alpha is left. Okay, and now I can take this out of the square root and it becomes d over 2, and then you have the square root of 5 minus 4 sine alpha. Okay, right, so that's it. And then that would be AC in terms of D. So now going back to this, here we have AC, so we can put in all of this into that. Okay, and let's just look at this. So it looks like we're on the right track. We just wrote D over 2 instead of putting all of this over 2, which is the same thing. So I'm just going to rewrite it like that to prove it. So it's going to be D 5 minus 4 sine alpha over 2 times by, so that this is the AC, times by the tan of theta. Okay, and then we have what we needed to prove. Okay, so B, calculate H if D is 300, alpha is 32, and theta is 63. So once again, just substitution. So H is equal to D is 300, and then 5 minus 4 sine of 32 over 2, and then times by tan of 63. Okay. Okay, times 5 minus 4 sine 32 over 2 times by tan 63. So that gives us 499.63. And H is a distance, and units is in meters again. Okay, so I think that is it. And then we are done with this video.